the amount or the volume that is being loaded on a particular ship. If you look in the area that's circled, these are petroleum storage tanks that have what's called floating roofs. So I could very quickly, over the course of a week, monitor which tanks are full, which tanks are empty, and have an assessment of how much petroleum is moving in and out of the port. Again, for industrial applications, this is quite useful. Now, if we come to an area that's probably more familiar to you, and again, I apologize if my pronunciation isn't great. So this is a region here in Thailand that was collected on the 5th of January. This is in the Trat province, if I'm pronouncing that correctly. But you see a lot of the areas close to the shore here where we have some sediment coming into the ocean. Again, if we wanted to monitor this on a very regular basis, monthly or weekly, we would be able to measure the amount of sediment coming into the ocean. If that was useful in understanding what level of sediment is coming off of agricultural operations, again, having current information and being able to use it quickly will enable us to do this. This image is quite interesting here. So this is in Chonburi province. On the 15th, you see what I have here. Actually, I'm going to see if I can pause this just for a second. So this is an old base map. So if I went to, this is me going to Google Earth, looking at this particular region. This data is probably 18, 24, 36 months old. So if I wanted to know what is the state of my water resources in January, on the 15th of January this year, within that circle is imagery that we collected just a couple of months ago in this region, and I can actually see the water levels in some of these reservoir areas. So I'm just sliding over the new data compared to the old data. If we look at this reservoir down in the lower right-hand side, we can see a few weeks ago that reservoir was completely empty. Now again, as we get new imagery of this, we can see when the reservoir fills back up again. If the agricultural operations are using that water to irrigate their fields, this is really important to understand. When is this reservoir going to be empty? What are the water levels at which we need to be concerned, maybe control how much water is used for irrigation?
Well, actually, this brings to mind an important point. As we're collecting imagery over time, we're actually storing and keeping all of that imagery. So when an event happens, you will be able to go into our archive and not just see kind of how the reservoir looks today, but saw how it looked yesterday, 1 month ago, 1 year ago, and it allows you to do something we call kind of forensic analysis. So what were the precursor events that led up to a crisis, a disaster, or perhaps even like a bumper agricultural yield that year? You'd be able to go back and examine all of the causal factors because this data set will have been captured and stored and made available to you.
That's a very good point. So we'll be storing a lot of information, and the value of our data is not just in a single day, but it's over the course of time that will enable us to make, I think, much better management decisions with environmental resources, agriculture and infrastructure, things like that. A couple other applications I wanted to show you. If we're talking about natural resources and infrastructure, this was a news article that I saw yesterday on the internet. I'm sure those of you who live here are very familiar with what's going on this time of year in Thailand. That's a picture that's pretty hazy. This is a quote from the article. So it's an annual problem. Obviously, I heard from our partners yesterday that several commercial passenger flights were actually turned back from the airport because the visibility conditions for the pilots, they were so bad. Understanding where does this smoke come from? Obviously you know that it comes from someplace in the north, but being able to identify the origin points of the fires that cause a lot of this smoke is actually very useful from a health standpoint. Having all this smoke in the air probably isn't the healthiest thing in the world, and also from a visibility, practical standpoint, this impacts the economy by planes not being able to land here. So this is an image that was captured just last week. This is in Kambaiti, Myanmar. But again, being able to identify points of origin of fires before they are large. So this is when some of these fires, there's not a lot of smoke around them, they're just starting to burn. And if you have access to this information before the smoke becomes a serious problem, and understanding maybe over the course of a couple of weeks there are 5 fires in this region, or 6 or 7, but understanding where some of the early fires originate. So maybe working with a neighboring country's government where they can potentially try to control some of the smoke problems that you have here in Thailand. This is here in Thailand. This is, again, just a few days ago. This was last week on the 9th of March. Phitsanulok province, I'm guessing. Not a very pretty base map. This is what I find when I look in the typical base map of the country. Again, this information is outdated. It doesn't really tell us what's going on today. This is an image that we captured on the 9th of March. You can see, we're going to try to point if I have do I have a laser pointer here? I do. Okay. You can see this is a pretty small agricultural fire that started, and apparently I would guess that the wind currents are floating, drifting this way. A lot of the smoke is building up here. But then right here, this seems to be a much larger scale fire. And of course, having access to information before and after this occurs, we can see, which fields the fire started on, and of course where the smoke is tracking. And as we have more satellites in space, being able to monitor the buildup of smoke, the pattern at which it drifts across the countryside, enables us to manage it much, much better.
And that image, correct me if I'm wrong, is actually from a slightly older version of software. It's captured recently, but you'll see the quality of it isn't as high as we can reach. But even with quality at this level, you can find the sources of wildfires. So I just want to emphasize that while quality is a key aspect, just getting any image is often better than getting no images.
So we'll move away from some of the environmental, the smoke-related issues for a minute. But again, if we're looking at very large environmental operations like mineral extraction, this sort of data captured on a regular basis will be able to answer some very critical questions. Again, this is an image captured in December from Myanmar, but having subsequent data will allow us to estimate the volume of earth that was excavated or moved on a weekly or a monthly basis. In some of these mineral extraction operations, they utilize sediment ponds or settling ponds. Of course, oftentimes when those things mix with nearby water sources like rivers, then you get pollution. So actually being able to keep tabs on what the condition of these ponds, if they're getting close to being full at the top. And of course, this being in another country, but perhaps there's rivers that come from one country to the other, you want to be able to protect your water sources, so understanding if there are risks to your rivers of pollution, this is a very valuable monitoring device. And of course, then new support infrastructure. So if there are new roads that go in place, that implies that there might be more traffic in a particular area. That helps us to plan if there, again, traffic can impact areas in a variety of different ways. And again, also to emphasize the level of detail of things we can monitor. So I'm sure everyone here has seen large power lines. The actual power line itself is not 3 meters, it's actually quite narrow, right? But if we look in this image, we can actually see the power lines and we can see the towers. So if we're doing some sort of new construction with electric utility infrastructure, electric transmission infrastructure, and then we want to monitor perhaps vegetation encroachment in those corridors, maybe after a storm, if some of the vegetation has been impacted or if there's flooding nearby, we want to be able to identify where those power lines are and then conditions around them so that we can keep them safe and keep them producing power. And finally, we've just been looking at pictures and pointing things out. Those of you who work with geographic information systems, GIS or remote sensing, know that really a lot of the power or the information that comes from satellite imagery can be uncovered with sets of tools that allow us to do things like land use identification or land use classification. So this is an example of an agricultural area with some rivers, with some built-up infrastructure, where we actually ran a land use classification algorithm, and we were able to identify several different land